Welcome back. Before we proceed, let's review our ideas of temperature developed so far. We should remember that we have defined temperature using the zeroth law of thermodynamics, which tells us that temperatures are nothing but labels on isotherms. The same label on corresponding isotherms in the state space of various systems. Okay. A scale of temperature allows us to create these labels in a proper method. But even then, some amount of arbitrariness is involved. We have defined a convenient reference system, we have defined its reference state, we have defined a temperature, or we have assigned a temperature to that reference state, we have devised a scheme of measuring the temperature of a system. This we have done for the historic Celsius scale, this we have done for the Kelvin scale. But even then questions arise, why water, why triple point? The answer is convenience and a reasonably good, repeatable, reproducible standard. So standardization and convenience, these are the main reasons. But remember that one disadvantage of the scales of temperature is that we end up with numbers like 0 degrees C, 300 Kelvin, etc. We know that for example, currently it is not very warm here. So the temperature of this room is about 26 degree C. Someone out there is preparing a cup of coffee for me, water is being boiled. So temperature of that boiling water will be say 100 degrees C. Because we are on a scale, a numerical scale, we are very comfortable with the fact that hot things have a higher number, not so hot things have a lower number. So the temperature scales give us an idea of larger numbers, higher temperature, hotter systems, lower numbers, cooler temperatures, colder systems. So ice is cooler than steam. So we are very comfortable with the fact that the temperature on either the Celsius scale or on the Kelvin scale for ice is lower than the corresponding temperature of steam. But remember, this higher and lower is not defined thermodynamically. We have created this idea because of our scales. Thermodynamics only says, particularly when you define temperature using zeroth law, that all you need is different isotherms should have different temperature labels. And zeroth law tells us that if the temperature of two systems is the same, that means they are isothermal states and they will not transfer heat between themselves if allowed to transfer heat across a diathermic wall. That is it. It does not say that if you bring in two systems whose states are not isothermal, allow them to interact across a diathermic wall. Well, zeroth law says that there may be some heat interaction, but zeroth law does not say the direction in which that heat interaction takes place. Zeroth law does not define a higher temperature and lower temperature. That will be defined using the second law of thermodynamics, which we will study after a few weeks. Thank you.